A team of scientists has studied the unusual galaxy cluster Abell 2744, nicknamed Pandora's cluster. Using telescopes in space and on the ground, including the NASA ESA Hubble Space Telescope and ESO's Very Large Telescope, they have discovered that it was formed by the simultaneous pileup of at least 4 separate galaxy clusters. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. When huge clusters of galaxies crash together, the resulting mess is a treasure trove of information. Observing these cosmic pileups lets astronomers reconstruct events that have happened over hundreds of millions of years. It also lets them study how different types of matter behave during these collisions. The galaxies in Pandora's cluster are clearly visible in images from Hubble and ESO's Very Large Telescope, but they only make up about 5% of the cluster's mass. About 20% is hot gas, which is shown here in pink. This gas is visible thanks to its X-ray emission, which can be detected with NASA's Chandra satellite. The lion's share of mass in the cluster, about 75%, is dark matter. The dark matter cannot be seen directly and is somewhat of a mystery in modern-day astronomy. But there is a trick astronomers can use to find out its location. By looking at the way that gravity distorts light from more distant galaxies, they can work out where dark matter is hiding. This lets the astronomers make a detailed map of where the dark matter is, shown here in blue. Comparing the location of the galaxies, the hot gas and the dark matter shows that this is not a simple crash between two clusters. By reconstructing the history of Pandora's cluster, astronomers think that it must have formed from 4 different clusters involved in a series of collisions over a period of some 350 million years. It seems that the complex collision has separated out some of the hot gas and dark matter, so that they now lie apart from the visible galaxies. Near the core of Abell 2744, the gas of one cluster has collided with that of another to create a shockwave. The dark matter passed through the collision unaffected. In another part of the cluster, there seem to be galaxies and dark matter, but no hot gas. The gas may have been stripped away during the collision, leaving behind no more than a faint trail. Even stranger features lie in the outer parts of the cluster. One region contains lots of dark matter, but no luminous galaxies or hot gas. A separate, ghostly clump of gas has been ejected, which precedes rather than follows the associated dark matter. This puzzling arrangement may be telling astronomers something about how dark matter behaves and how the various ingredients of the universe interact with each other. Galaxy clusters are the largest objects in the universe to be held together by their own gravity, and understanding how they form and evolve is a vital aspect of unraveling the history of the cosmos. Learning more about dark matter not only furthers our understanding of clusters, but it also takes us a little closer to fathoming the nature of this mysterious and elusive substance.